Let's set f contains all the functions from a comma b to r such that f is continuous on ab and differentiable on open interval a comma b. Which of the following options is correct? So if we consider the first option, there exists a non-constant f such that f of x minus f of y is less than or equal to mod of x minus y whole square for all x comma y belongs to ab. So suppose like if f of x minus f of y mod of f of y is less than or equal to x minus y whole square for all x comma y. So that means then for any x and a small h, we can see that f of x plus h minus f of x by this h is less than or equal to this h, and this tends to 0. So that means this f dash of x, mod of f dash of x is less than or equal to 0. That means f dash of x is 0 for all x. So that means f is a constant function for all x. So therefore like first option is incorrect. Now if we consider the second option, so if f belongs to f, so that means if f is a continuous and differentiable function on the interval a comma b, then there exists distinct x1 x2 such that f of x minus f of x2 divided by x1 minus x2 is f dash of x0. This is not true every time, because if we consider a counter example, let's say f of x is some e to the power of x. So if f of x is e to the power of x, so that means on the interval, let's take 0 to 1. So this is satisfying the differentiability property. So this is continuous on closed 0 to 1, and this is also differentiable on open 0 to 1. So now like if we consider f dash of x, so this f dash of x is nothing but e to the power of x. So that means like if we consider this so f dash of 0, so f dash of 0 is nothing but 1, and let's take x0 as some 0. Now like if we consider every secant slope, that is e to the power of x1 minus e to the power of x2 by x1 minus x2, so they're saying like this equals e to the power of c, right, like for some c belongs to 0 to 1. This is like by mean value theorem we can say this particular thing. So that means like all secant slopes are greater than 1. So that means like between any 2 points we can't have a secant slope equal to 1. So therefore like the second statement is also incorrect. And similarly if we consider the fourth statement, so it is saying that f dash of x